Okay, so we have completed discussing about by consumer in the previous session. So today the topic is primitive type functional interfaces in JDK 1.8. So you get a lot of interview questions on top of the primitive type function interfaces. So before understanding the primitive type function interfaces, I want you to understand about the three other topics. This is very important topic. First one is the concept of autoboxing. Second topic is autoboxing is there and auto unboxing is there. Okay. And the third topic is generics. So type parameter. Okay. So these topics are necessary to understand about the primitive type function interfaces. So first let us understand what is autoboxing. So before understanding the autoboxing, so we have completed discussing about the topics here. Okay, let me show you the topics. Okay, so we have completed discussing about the predicate. What is predicate? We know. What is function? We know. Consumer and supplier. And by predicate we know. By function we know. By consumer we know. Okay. So these 7 interfaces we have discussed. We have completed discussing about these 7 interfaces. So predicate function. Okay, when you look at this particular column, so they take only one input, right? The argument is there one argument function interfaces which takes one input, isn't it? So they always depend upon an input and only one input, right? And when you look at this column, they depend upon 2 inputs. That's why they call what? No, the by is prefixed with these interfaces. By predicate, by function, by consumer. They take 2 inputs. Right? And again, when you look at the inputs specifically, the inputs are of the object types. Okay, so what type of input they are going to expect? They are going to expect object types input. Object type input. So you are allowed to pass input in the form of what type? The form of object types. Right? Object types. So when you are dealing with these interfaces, they expect inputs and they give some output in the form of return type. And the input and the output type are always in the form of object types. They are not of primitive types. Please understand. So if you look at this particular table, okay, this table has the primitive type data types and the wrapper class type data types. Okay. For the above interfaces, for these interfaces, all they expect is they accept the data in the form of wrapper class type. You cannot pass the data in the form of primitive type. Right? Only this data should be in the form of wrapper class type. You can pass int into the form of wrapper class type. Integer. You cannot pass int. Okay, int is not accepted. So only integer is accepted. When you want to pass the floating point value, you can pass the wrapper class type of float. You cannot pass the primitive type. So primitive types are not accepted. Right? So having said this, let me introduce the concept of what? Autoboxing. Autoboxing. Auto means automatic. What does the boxing means? Okay, I will give you the definition of autoboxing. Okay, the process of the automatic conversion of primitive data type. Primitive types to their corresponding wrapper class type. The corresponding wrapper classes is called as autoboxing. So I am just repeatedly saying something like autoboxing. Autoboxing means it happens, this conversion will happen automatically, and this conversion will take care by the compiler. How the compiler is going to take care of this conversion? Okay, to understand this, let me help you with a small example. Okay, the example program is like, I have something like a class A and the main method public static void main. So inside this main method, what I'm trying to do here is I'm taking an integer. Okay, I want to store an integer value, something like 100. So 100 is an integer value. I want to assign this 100 to the wrapper class type. To what? Wrapper class type. So this 100 is a value. Okay, this 100. Okay, let me copy this in the plain screen. Okay, I'm trying to do this. Look at this. This 100 is representing a number. Okay, this number is of what type? This number is of primitive type. The values are always primitive. The numbers are always, the data that you are representing are always primitive. This number is primitive type. You are assigning the primitive type to the wrapper class type. This integer is representing what? Wrapper class type, right? Wrapper class type. Okay, so a primitive value is getting assigned to wrapper class. There is a problem here. Okay, if you are doing like this, no problem. Integer I equal to 100. Okay, now both are primitives. This 100 is primitive as well as this integer int is also primitive. Both are primitives and there is no problem with this line of code. There is no problem. This is completely okay, right? This is completely okay. But this logic is not okay. This logic is a bad logic. I mean, this logic will give you some trouble. Why it will give you some trouble? You are trying to assign the value which is of primitive type to the wrapper class type, right? Till Java 1.4 version, this is not valid. Till Java 1.4 version, if you are writing a code like this and if you are trying to execute this code, let me show that. System.out.println. Okay, this is my data. I am assigning the primitive type to the wrapper class type and I am just trying to print the value inside the variable I. So till Java 1.4 it is not valid. What Java 1.4 says, till Java 1.4 you cannot assign the primitive type directly to the wrapper class type. You will get an error. Where is the proof that you are getting an error? Okay, let me save this code and let me run this in Java 1.4. Java C space hyphen source space 1.4. I am running the 1.4 version. Okay, a.java. Okay, it is giving me an error. Say, look at this. Int cannot be converted to integer. You will get this error if you run this in Java 1.5. But from Java 1.5 there will be no such errors. Okay, from Java 1.5 you will not get error. If I use Java 1.5, Java C space. Okay, instead of 1.4, if I use 1.5, I hope my screen is visible. Let me increase the font size. 0.5. Okay, from 1.5 version, you will not get any error. You will get just warnings here. And after this, if you compile and if you execute this code, the output is there 100. There is no error. These are the warnings. You can leave. You can ignore this. From Java 1.5, there is no error. Why you are getting error till 1.4 and why not from 1.5? That is the question, right? That is the $1 billion question. What is happening internally is from Java 1.5. From Java 1.5 version, okay, the compiler will come into the picture. Okay, the compiler takes care of the conversion. What kind of conversion it is doing? Compiler will recognize the developer is trying to assign the primitive value to the wrapper class type. So compiler will recognize this and compiler will do the conversion. Compiler will convert the primitive type to the wrapper class type automatically. Wrapper class type. How this conversion will happen? Automatically. This is called as, and you call this conversion as, and you call this conversion as autoboxing. Okay, the definition is very simple. Autoboxing means automatic conversion of primitive type to the wrapper class type. This conversion will be taken care by the compiler. You do not want to do anything. Okay, till 1.4 it is not valid, but from 1.5 the Java people has introduced this concept internally so that the compiler will take care of this conversion internally. Okay, this concept is called as what? Auto boxing. Okay, what compiler will do? Compiler will recognize this piece of code. Okay, let me go back here. Okay, so these are the code that we have. This is the actual code, isn't it? This is the code. Compiler will recognize the piece of code. Okay, it recognizes these two data types are incompatible. It will do the conversion internally. It will convert this code like this. You don't see this actually, but internally this is happening. Compiler will do what? Compiler will rewrite this code like the code that I'm writing now. Integer I equal to integer dot value of 10. Okay, this piece of code will be written by the compiler. Okay, you don't see these things, but these things are happening internally. When you write this code, these two lines of code, compiler will introduce this code in between, and the process of introducing this code, okay, the process of converting the primitive type to the wrapper class type is called as what? Autoboxing. That's it. Why we are discussing this, you will understand this shortly. Okay, very important questions in the interview. What is autoboxing? Okay, let me put this sample code for your reference. So what is autoboxing? The automatic conversion of primitive types to their corresponding wrapper classes is called as what? Autoboxing. This will be done by the compiler, and it was introduced. When it was introduced? In JDK 1.5 version. JDK 1.5 version. Okay, example code. I am attaching the example code here. Okay, this is called as what? The auto box. Very simple, isn't it? Okay, you will get this question very often. Okay, now second one is what is auto unboxing. Okay, so if you know what is auto boxing, then you already know what is auto unboxing. Okay, auto unboxing is just the opposite. Auto unboxing is what? It is just the opposite. Okay? When I say just the opposite, the automatic conversion of wrapper class types to primitive types. The automatic conversion of wrapper class type to their corresponding primitive types. Primitive types is called as auto unboxing. Just the opposite of auto boxing is called as what? The auto unboxing. Okay, how the example code for the auto unboxing is will look like this, guys. Very simple. Now let me take another example. Even this was introduced in JDK 1.5 version. Okay, same. If I have an integer, I like this. Integer I equal to new integer. Okay, so this is of wrapper class type. I am storing a value 10 by using what type? Wrapper class type, object type. After this, what I am doing here, I am taking the primitive type x and I am assigning the wrapper type here. This I is getting assigned to, this I is of what type? Wrapper class type is getting assigned to primitive type. When you do this, okay, there should be a balance, right? You look at LHS, I mean RHS, right hand side is something of different type, which is of wrapper class type. On left hand side is something which is of a primitive type. They should get balanced, okay? And Java is taking care of balancing this line. How it is taking care of balancing this line? It will ensure that this data type is getting converted to the primitive type itself. Okay, this data type should match this one, okay? Internally it is going to convert this. That conversion is called as what? The auto unboxing. Auto unboxing. Right? Wrapper class to primitive type is called as what? Auto unboxing. What it is doing internally? Internally it is adding a piece of code like integer x equal to I dot int value. Okay, this is the piece of code that is writing internally. Okay, this is taken care by the compiler itself. You do not have to do anything here. Compiler will take care of this. It will take care of the conversion. Okay, just the opposite thing is called as what? Auto unboxing. If I run this code, Let me use System.out.println. Okay, and I want to print x. If I run this piece of code, let me to JDK 1.5, you get the value 10. No issues. Till 1. From 1.5 it is valid, but till 1.4 it is invalid. If I use 1.4 version, you get the incompatible type error. Integer cannot be converted to int. So from 1.5 it is valid. Internally, compiler is taking care of what? The conversion. That conversion is called as what? Auto unboxing. Very simple. So I will help you with one diagram. You can just imagine this diagram. Okay. The diagram is going to be like this. Let me take two things here. Okay. When you have a wrapper object, and when you have primitives. Minute. This is happening. When you have wrapper object on one side, when you have primitives, primitive data type. Okay. When you approach like this, wrapper to primitive type, is called as what? Auto unboxing. Auto unboxing. When you approach the opposite way, this one, it is called as what? Converting from primitive type to wrapper class type, auto boxing. Okay, both unboxing and both auto boxing and auto unboxing is taken care by the compiler, not the programmer. This process will be handled by the compiler itself. Okay, so this is all about what? Auto boxing and the auto unboxing. I hope you have got some idea. Very simple for the interview room. You can answer these two lines. You can remember this one line and you can answer it for the auto unboxing also by just changing the types. Okay, now third one is generic type parameter. So when I say generic type parameter, I think we have come across this type very often. For example, you have an array list. You know what I mean? Array list is the, you know what is an array list? The array list is going to accept the type parameter, isn't it? Okay, this type parameter should always be of what type? Wrapper class type. That's normal. Okay, AL equal to new array list. So when I say this, okay, so you have come across the array list. You know, we have discussed a lot of programs on top of collections. Inside the collection framework, each and every class is going to accept a kind of type, isn't it? Each and every class is going to accept a kind of type. Okay? This type can always be the wrapper class type. You cannot do this. This is valid, but when you do like this, when you're keeping the generic type as integer, primitive type, this is completely invalid. This line is invalid, not at all accepted, because this part is what? The type parameter, especially the part, okay, the generic type. This part is what? The type parameter. This type parameter should always be of the wrapper class type. You cannot initialize the type parameter. You cannot assign the type parameter as a primitive type. When you do that, it is going to give you an error. It's not at all allowed, right? Okay, so this part is called as what? The type parameter. What is it? Type parameter. Okay? And the type parameter should always be what? Always be of the wrapper class type. Type parameter. Okay, so what is the generic type parameter? Please be informed that in the collection classes, collections may like this wrong, but in the collection classes, when you are dealing with what? When you are dealing with the homogeneous header, the type parameter should always be of wrapper class type, and primitive types are not accepted. Types are not accepted. Okay, so this knowledge is enough to understand what this knowledge is mandatory to understand primitive type functional interfaces. Primitive type functional interfaces are very easy. Okay, let me introduce the primitive type functional interfaces now. Okay, we know what is autoboxing, we got to know what is auto unboxing. Now we will understand why we are discussing this autoboxing and auto unboxing to understand this primitive type functional interfaces. Okay, so I will give you the small program. Okay, in the one of the interviews, okay, there was a question. What kind of question is that? They have given this piece of code, guys. Okay, the piece of code is like this. Let me delete this. A predicate. They have given a predicate, and this predicate is accepting an integer. This integer is of what type? Input type. Okay, let me import the predicate. Predicate, and this is accepting what? Input type. Type parameter is of what type? Integer type. Okay, and so before even understanding this, okay, let me comment this. They have given an array of integer. Integer a equal to some numbers are there inside this integer array 1, 2, 3, 4, 5, 6. There are 6 numbers. These 6 numbers are stored in the integer array. This integer array is of what type? A primitive type. Okay. After this, they have given a predicate. Okay, this predicate is going to do an operation. What kind of operation it is going to do? It will accept the integer and it has to find, it has to filter whether the given number, it has to check whether the given number is an even number or not. Right? So this is the logic. I percentage of 2 double equal W. This is the logic, typical logic. Okay. After this, I can run a for loop. By running this for loop, I can ensure that each and every number will be iterated, each and every number will be taken, and that number will be checked upon the given predicate, which is what? P dot test method. This test method will accept each and every number that is already there inside the integer array, right? And after testing this, you will get whether the number is even or not. Only it is going to print the even numbers. Okay, this is so good so far. They have asked me the question like, there is a problem in this. There is a big problem in this approach. However, you are getting an answer that is fine. You are getting an answer that is completely fine. But there is a big problem with this approach. What is that problem? That we need to understand first. Okay, so let me help you to understand this problem. So this is the code page. This is the code. Output wise, you are able to filter the even numbers. You are able to extract the even numbers from the output. No doubts about it. You are able to extract the even numbers from the from this particular logic. But they are saying there is a problem in this code. What is the problem that we will understand? Okay. Now you see the input is of what type? Each and every input. When you consider the input, is of primitive type. 1, 2, 3, 4, 5, 6. There are 6 numbers. And each and every number is of what type? Primitive type, primitive data type. Okay. But the predicate is accepting what type? Wrapper class type. Focus here, focus here. Okay. The data is of primitive type. One observation. And this predicate is designed to accept of what type? Wrapper type. Wrapper class type. Wrapper class type. Because this is a type parameter, you cannot give the primitive type here. That is not possible. The rule is predicate can accept the input in the form of wrapper class type only. But the input values are of what type? Integer type. 1 is integer, 2 is integer, and so on. Okay, what is actually happening? Okay, you are passing an integer. Okay, 1 is being passed. Firstly, 1 is being passed. 1 is getting passed as an input. Okay, and when you are passing 1, don't you think that this 1 is of primitive type and this 1 needs to get converted to of what type? The wrapper class type. It means this is the input. Input is of primitive type and it has to get converted to what type? Integer type, because this predicate is accepting only the wrapper class type. It is designed to accept the wrapper class object. The number needs to get a conversion from this integer type to this integer type, which is called as what? Autoboxing. Okay, this autoboxing will be taken care by what? Compiler. One thing, first step. First step, before even proceeding in the processing, first the data needs to get this conversion. Okay. Auto boxing needs to happen. So this is what the auto boxing. First point is representing this. Right? After now the data is converted to integer type. There is one more problem here. Okay, you can observe here I percentage of 2. I percentage of 2. In Java, all the arithmetic operations. So this is a second thread that we have. In Java, this is a second thread. In Java, all the arithmetic operation can happen only on the primitive types. Let me explain. Please be informed that in Java, all the arithmetic operations, or the mathematical operation, all the arithmetic operations are performed on primitive data types. Right? Firstly, what the Java is doing, the compiler is converting the primitive type to the wrapper class type. Okay, this has happened. To accept the input, after accepting the input, okay, after completing this part, to perform the arithmetic operation, again there should be a conversion. Okay, the wrapper class type should get converted to what type? To get converted to object. In primitive type. You have this. Okay, this integer needs to get converted to this integer. To perform what? To perform integer percentage of 2 double equal to 0. To make this up. Okay, this process is called as what? Auto unboxing. Auto unboxing. Okay. So for the first data, which is 1 is of primitive type, and internally compiler is coming into the picture, and compiler is trying to do the auto boxing, and again it is doing the auto unboxing to complete the calculation. 2 operations it is doing for one data. How many data we have? You have 1 and you have 2, right? And you have 3. For each and every data, this conversion is required. Lot of conversion is required. For one data, 2 conversions. For 6 data, for 6 values, 12 conversion is required. 12 times the conversion is required. Auto boxing is required, auto unboxing is required, which is taken care by the compiler itself. Don't you think that because of this internal conversions, lot of conversion is happening internally without your knowledge? Okay, due to this internal conversion, don't you think that there will be some reduction in the performance? You don't see anything, guys. Okay, if I just click on run button, you are able to see the output. Why we are caring about this? You're okay with the output, but internally when you're dealing with a large set of data, there is a problem. Okay, there will be a delay here. Now we have small set of data, no issues. If you are dealing with a large set of data, infinite data, you cannot expect the compiler to do the auto boxing, unboxing very often. That is the time consuming process, and the performance wise it is going to be down. The reduction is performance. Right? In order to overcome this, okay, in order to overcome this kind of situation, okay, there is a concept called what? Primitive type functional interfaces for predicate. To overcome, please be informed that to overcome the continuous process of auto boxing and auto unboxing by the compiler for the normal predicate, single argument predicate, which accepts integer type as an input. Okay. We can opt for primitive type function interface. Okay, what is primitive type function interface? I will give you now. Okay, so there is a problem here. In order to overcome this problem, they have introduced what? Primitive type function interfaces. Okay, now the question is, what is primitive type function interface? First, primitive type function interface. When you already know that you're going to deal with a large set of integer data, primitive type integer data. When you already know that you're going to deal with a large set of integer data, so it means what? The input is always integer type, primitive integer type. Okay? Then you can use this word. Then you can use this interface, which is interface. Name of the interface is int predicate. Okay. When you already know that you are going to deal with the large of, okay, go back to this code. When you already know that you are going to deal with this, the input type is of primitive type, and it is going to store a large set of data. Instead of opting for the normal ordinary predicate, you can opt for the int predicate. This one, there is a new predicate called what? There is a new functional interface called as what? The int predicate. Okay. It is not going to accept any variable because the int itself says the input type is always integer. Okay, so here is there is no type parameter. Okay, ordinary predicate, you know what is ordinary predicate? Okay, so interface predicate, this is the classical predicate which has a type parameter. It's going to accept the type parameter as t. Okay, this t is the input type, that is up to the developer what data is going to deal with. Okay, since the developer is going to deal with the integer data in the example, right, and the t is of input type. Okay, but for the int predicate, the int itself says that the input is always of integer type, so there is no type parameter. Okay, and the t is used to accept primitive. You have to accept a primitive type int as the primitive type. Okay. So the name of the method is going to be like public boolean. Return type is always boolean, but the input type is what? The input type is going to be what? Int type. Test int type. Input type is always the primitive type. Okay, let us correct this code. Let us re-correct this code. Okay, if I want to use this int predicate, okay, you do not have to define the type parameter. This is not required because the int predicate itself says that I am going to accept the integer values. Okay, IP equal to the same logic, the same business logic. I can copy and paste it here. The same business logic I can copy and paste it here, and the same for loop I can run it here. Let me remove this. Okay, let me keep this for the understanding. X1 here. Let me keep it as X1. Let me keep it as X1. Okay. If I run this code, the output is going to be same. 246, 246. This 246 is for predicate, and this 246 is for int predicate. But internally, what is happening? That conversion is avoided. That autoboxing and auto unboxing conversion. Okay, the conversion that you are seeing it here is not going to be with this int type. Okay. Okay, this is the code, and you have the data. Okay, the data is what? This is the data that you have. Okay, this is our data. One, two, three, four, five, six. Okay, in predicate is going to accept the data as the integer itself. Okay, it is going to accept the data as integer itself. Okay, first the one will be taken, one will be tested upon this logic. Okay, so one is of what type? One is of integer type, primitive type. Okay, it will go inside as a primitive. Okay, and there is no conversion required because this is also primitive type. This is also expecting the primitive type. This I is expecting the primitive type. So no conversion is required, right? So if you are avoiding this conversion, if you are avoiding the autoboxing internal conversions, you are going to do what? This like the performance is increased for the large set of data. Performance is increase. So you are overcoming the drawbacks that you have for the ordinary predicate with the in predicate. Are able to follow? Performance is increased. Earlier, you had seen that lot of internal conversion has happened because of the auto boxing and the auto unboxing by the compiler. So the in predicate will ensure that no auto boxing and no auto unboxing is happening, because the int values, the values that you are passing, is accepted because this value is same as this value. Okay, this is expecting the primitive type itself, so no conversion is required. Okay, and if you are dealing with a large set of numerical numbers, if you are dealing with a large set of numerical values, you can go for what? In predicate. Like this in predicate, there are two other predicates which are like the long predicate is there, and you have what? The double predicate. This long predicate and this double predicate are same like the in predicate. Okay, no explanation is required for this, because you are dealing with the double values. For example, let me remove this. If the data is of what? Double type. The double means 1 point floating point values, 1.00, 2.323, 3.55, 4.66, 5.77, 6.99. Okay. And you can typically use the interface called double predicate interface. Okay. This double predicate interface will ensure, okay, you can write a different logic here. So double predicate, you cannot you cannot use the modular operation. Always it is going to return what? It is going to return the Boolean value. So you can use like this. It's greater than or equal to 5.00. Okay, this needs to be converted to what? Double. Okay, let me import the double predicate. Okay, this is a simple logic. I am just taking what is it? P.test. Okay, IP.test. Okay. The logic is I am taking an input of double type, primitive type. I am testing upon this logic. Okay, logic is going to check if the each and every data is greater than or equal to 5.0 or not. If it is greater than or equal to 5.0, it is going to return, or else it is going to return. Let us see what are the values that you are going to get. Only 5.77, 6.99 are satisfying this condition. Right? There is no conversion is required here. Double itself says that type parameter is of double type. You can pass all the data which is of double type, primitive type. Internally, no conversion is happening here. Okay, no concept of auto boxing and no concept of auto unboxing. Same thing apply for long data type. If you are dealing with the data of long type. Okay, for example, long type, right? Long means you should use the suffix L. Each and every number has to be suffixed with the letter L. 3L, 4L, you have something like 5L, and you have something like what? 6L. Okay, let me take it as A. And there is to deal with long data, you have a predicate called long predicate. Okay, let me import this, and you can keep the same logic. Okay, you can calculate the even numbers. So this is the typical logic for to deal with the long data. You have an error here. Let me comment this. Okay, 246. Right. So what is the advantage of dealing with this kind of data? No internal conversion is happening here. Auto boxing, and auto unboxing is not at all happening. Okay, let us visualize this, and we will close this class today. Let me visualize this. Okay, let me take the interface. Okay. So this is the predicate. Okay. Now we have discussed about three predicate. What are the predicates that we have discussed about? Primitive type functional interfaces. Okay, we are discussing about the predicate. For the predicate, there are three primitive type functional interfaces. One is int predicate, second one is long predicate, and third one is double predicate. right? And the input type, okay, if you are dealing with if you are storing the, if you have the stored data in the form of array, for example, if you have the integer data 2 3 4 5 6, okay? So when we are using int predicate, okay, the input that you are sending will be of what type? Integer primitive, in primitive type, okay? And you are writing a processing logic. Processing logic is written by you, and for this processing logic there is no, you do not need to keep any, I mean the compiler will not do any conversion like auto boxing is not there. Auto boxing concept and auto unboxing concept is avoided. Unboxing is avoided, okay? When you avoid this auto boxing and auto unboxing, performance is increased. Okay, the int is going to, this primitive type integer is going as primitive type integer only, and no conversion is happening, and the output you are getting in the form of what type? Boolean type. Because it depends upon the processing logic. Whatever the logic that you write, you should ensure that it is returning the Boolean itself. Likewise, if you are dealing with the long predicate, you need to ensure that all the data, each and every data is of long type, and it will be processed, but no auto boxing and auto unboxing will happen, and output will be in the Boolean. If you are dealing with double data type, the same thing will happen. All the input will be in the of double type, right? Processing logic will ensure that no auto boxing and no auto unboxing is happening. Because of these reasons, the performance is always high comparatively with the predicate. Predicate is low in performance. Predicate is low in performance, whereas the primitive type predicates, primitive type predicates are high in performance because it is avoiding the auto boxing and the auto unboxing. The predicate is always low in performance. The primitive type predicates are high in performance. Okay. So these are the three important interfaces for the primitive type predicate: int predicate, long predicate, and the double predicate. Obviously, if you are not using this and if you are going for the legacy predicate, if you are going for the normal predicate, you will get the output, but the performance wise it will be affected. Okay, all it is always recommended when you are dealing only with integer data, use this. When you are dealing with the long data, use this. When you are dealing with the double data, use it. When the data is very specific, go for this. Right? When the data is not such, not having such specificity, you can go for the ordinary predicate. Right? So that's all about the today's class. Tomorrow we will understand about the function predicate and the consumer predicates. I mean, there are some few other predicates, primitive type predicates are there. Function primitive type, and we have the consumer not predicate. Sorry. Okay. And after understanding this, we'll start discussing about the stream APIs. Stream APIs, and only if you understand these topics, the stream APIs are going to be very easy. Okay. Trust me, you will not get this kind of information, especially for the Java 8 anywhere. So please join the classes every